Alright, this is your warm-up for your quiz today. It's on page 26 is where we're looking. Page 26, where we have the warm-up for today's quiz, which we're going to go over right now. This first problem gives us a reaction that I'm not going to bother reading out loud, but it's there if you want it. And it asks how many grams of NaF form when 0.500 moles of HF react. Recall how many fractions we're supposed to use if you have grams and moles. Grams and moles together, that's going to be a 3-fraction problem. And as always, whatever they gave us is our given on top of our first fraction over 1. Make sure you're writing a number, a unit, and a chemical for every spot of our fractions. And since we're starting with HF, we're given HF, that's where our bridge is going to start. They're asking about NaF, so that's where our bridge is going to point. We do what goes up must come down, so if moles of HF are on top, the moles of HF are going to be at the bottom of the next fraction. And when we have moles on the bottom, that's our signal that it's time to use the bridge. Moles on the bottom, that's our signal it's time to use the bridge. So we go look at our bridge. It says 8 HF, so I'm going to put 8 moles of HF on bottom here. And we drive across the bridge. It says 2 NaF, so I'm going to put 2 NaF here. And then you have to ask yourself, am I supposed to put what unit here? I know they're asking for grams, but I cannot put grams here because this 2 came from the bridge. And remember, your bridge is always a mole bridge. It's a mole bridge. It is a number of moles. So we're going to put moles right here. And again, we're going to do what goes up must come down. So moles of NaF are coming to the bottom here. And now I've used moles of HF twice. I've used moles of NaF twice. I can't use any more moles anymore. I've used 4 moles twice with each chemical. That's all the moles we get. So on top, we're going to have to switch to something else. And the only thing left in this problem is grams of NaF, which is what they are asking me to find. Remember that anytime you have grams and moles in the same fraction, your number of moles is 1. And your number of grams comes from the periodic table. So if you go check your periodic table, the mass of sodium is 22.99. The mass of fluorine is, I think, 19. Yeah, 19. And you add that together. And that is your number of grams that goes in front here. And from here, we're sticking it in our calculator. Remember, anything on top you multiply. 0.5 times 2 times 41.99. Anything on bottom you divide. And if you've typed it in your calculator correctly, you should get 5.25 grams of NaF. And that's your final answer for 1A. When we read 1B, it asks, what is the percent yield if the reaction produces 4.2 grams of NaF? Percent yield, you need a formula for. I will put this formula on the board for you during the quiz, but you have to know what it means. Percent yield is the actual yield divided by the theoretical yield times 100. As we discussed in our notes, the actual yield is going to be a given number, and a yield is always a product. So it will be a given number for some product. The theoretical yield is what you find after doing a mole bridge. They will give you a reactant. You do the mole bridge from your reactant over to a product. and whatever you find after the mole bridge, that amount of product is your theoretical yield. Well, in part B here, they have given us a product. NAF is a product. So because this is a given product, that is my actual yield. So when I go to my formula, this 4.2 grams of NAF is going to go on top. Now the theoretical yield is what we find after we're given a reactant, we follow a mole bridge to a product, and whatever that amount of product is the theoretical yield. Well, guess what we did in part A? In part A, we did start with a reactant, follow a mole bridge to a product, and get an answer that was a number of grams of product. So this that we found in part A, that is the theoretical yield. So that's what I'm going to put on bottom here. And you should wind up with 80% as your answer after you do this formula in your calculator. Okay, let's look at number 3. Number 3 says calculate the number of moles of iron formed when 0.34 grams of Fe2O3 react. So again, moles and grams, that's going to be a 3-fraction problem. And what they gave us is going to be on top of the first fraction over 1. And what they gave us is where our bridge is going to start. And they're asking for moles of iron, so that other chemical in the problem, whatever they gave us is where the bridge starts. The other chemical they mention is where your bridge is going to point. From here, we do what goes up must come down. And your number of grams, again, will come from the periodic table. So you're going to have to do 2 times iron is 55.85, oxygen 3 times 16. If you add that up, I believe you get 159.7. Is that right? Yeah. You get 159.7, so that's your number of grams that's going to go in your second fraction. We have to switch on top. We've used grams twice, you can't use it again, so on top we have to switch to something else. So we're going to switch to moles, and it has to still be moles of Fe2O3 because we have not crossed to the bridge yet, so we can't switch chemicals. We can't make this just Fe on top because we haven't crossed the bridge to get on the iron side of the bridge yet. We're still on the starting side of the bridge, so this must be Fe2O3. And where grams and moles are in the same fraction, you're just using 1 mole. Then you do what goes up must come down again. And here, when we have moles on the bottom, that's our signal that this is where the bridge comes into play. So I look at my bridge, there's no number in front of Fe2O3. That means we're just going to use a 1. Follow the bridge, it's pointing at 2Fe. So on top I'm going to put 2Fe, and then I need a word here. Specifically, remember this bridge is always a mole bridge, so this is 2 moles of Fe. A toll is a toll, and a roll is a roll. And if we don't get no tolls, then we can't eat no rolls, and you have to pay in moles. This rounds to 0.004. It's a really small amount. Moles of iron. Okay, let's look at 3B. How many grams of iron metal are produced when 150 grams of Fe2O3 react? Well, grams and grams is 4 fractions, and as I've said before, when you do a 4 fraction problem, you really want to start your first fraction all the way on the edge of your paper, or you're going to run out of space. The number they gave us goes on top of the first fraction over 1. They gave us an amount of Fe2O3 again. And again, that's where my bridge is going to start also with Fe2O3. They're asking for grams of iron metal, so we're using the same bridge for part B. That's convenient. What goes up must come down. That uses grams of Fe2O3 twice. We can't use grams again, we have to switch. So on top we're going to switch to moles. And we have not crossed the bridge yet. We didn't cross the bridge yet, so this is still Fe2O3. We're still on the starting side of the bridge. Remember that wherever moles and grams are in the same fraction, you're going to use 1 mole, and your number of grams will come from the periodic table, which we actually found in part A how many grams this is. It's still 159.7. Then we do again, what goes up must come down. And now, where we have moles on the bottom, that's our signal. We're ready to start the bridge. So again, Fe2O3, there's just one of them. Cross the bridge, it's pointing at 2 iron. And once again, remember that bridge is a mole bridge. This is 2 moles of iron. One last time, what goes up must come down. And I've now used moles of Fe2O3 twice. I've used moles of iron twice. Can't use either of those again. We have to switch again. So all that's left to switch to is grams. And this time it'll be grams of iron, because now we have crossed the bridge. We are on the iron side of the bridge, so this is going to be grams of iron. Whenever grams and moles are in the same fraction, we go back to using 1 mole, kicking it old school. Our number of grams comes from the periodic table. It's 55.85. And when you put this through your calculator, you should get 104.92 grams of iron.